we're doing radiometric dating, and then we're going to be almost done. We're almost done. You guys have been great. You've been champs. I just want you to know that, okay? I know an hour and a half is a long time, so that goes for you too. But I know you can shut it off and go to the bathroom, so that's not fair. All right, so radiometric dating is the process of when they estimate how much of a radioactive element has already been lost in a rock. Those of you that already have physical science have already studied this, okay? And so you know what I'm talking about here. And all of these forms of dating have a lot of assumptions involved. And depending upon what assumption somebody makes, they're going to read the scientific data very differently. And that includes radiometric dating, even though it's a very technical way of trying to figure out how old things are. It still requires assumptions. Let's do carbon-14 dating first. Carbon-14 dating only works with something that was once alive and now it's dead. It doesn't work with just rocks, okay? It has to be something that was once alive and now it's dead. And the reason it works is, so they have other forms of dating that dates rocks. I just want you to like potassium argon dating, uranium lead dating, isochron dating. There are other forms. Carbon-14 dating, though, we're made up of predominantly carbon. It makes me think of Star Trek again, carbon life forms. Anyway, and so you have to forgive me. So carbon has 6 protons, and that's what makes it a carbon. 6 protons, 6 electrons. And most carbon around has 6 neutrons. But there are isotopes of that carbon. Some of them have 7 neutrons. Some of them have 8 neutrons. But they're all still carbon. The trick is once they get these other nuclei sometime, they can become unstable, and that's what makes them a radioactive isotope, is if their nucleus is unstable. Carbon-14 is unstable, and so therefore it is a radioactive isotope of carbon. It's still carbon, but it's not happy. And it actually, when it goes through the radioactive process, it turns into nitrogen that is happy and that is stable. That's what it does. So that would be the daughter product. Now, when cosmic rays come into the upper atmosphere and hit nitrogen, they can cause some issues and turn nitrogen into carbon-14. And then guess what? We breathe it in. Plants take in the carbon dioxide, right? And as the plants take in the carbon dioxide through photosynthesis, and we eat the plants, we're eating whatever carbon-14 percentage is in the atmosphere. Does that make sense? So we take it in. The plants take it in. We breathe some, but I know we're taking in more oxygen, but the point is we can eat it in the plants. So we take in whatever amount of carbon-14 is in the Earth's atmosphere while we're alive. And once we die, we're no longer taking in carbon-14. So from the time we die, you can tell how long, this is the idea of carbon-14 dating, you tell how long we've been dead by how much of that carbon-14 has left and turned into nitrogen. That's how they tell. So they have to make a ratio of carbon-14 has a half-life, which means half of it is totally gone into nitrogen in 5,730 years. They have to have a ratio to figure out how long you've been dead. And how they do that is they look at how much carbon-14 is in the atmosphere compared to carbon-12. And I think right now it's like 1 billionth. So out of every billion molecules, let's just say that's what it is, because it's very, excuse me, very small. There's 1 billion, so 1 in a billion is carbon-14. Well, so when we die, we're no longer taking it in, so it starts to deteriorate and go away, and therefore they see how this changes over time, and that's how they determine how long something has been dead. That's what carbon-14 tells you, how long something has been dead. Everybody with me? So that's how that works. Now the trick is this. Fossils that are supposed to be hundreds of billions of years, hundreds of millions of years old. Remember, the Earth is supposed to be 45, that's 4,500,000,000 years old. They found fossils that are supposed to be like 250 million years old. They still have carbon-14 in them. Well, that can't be, because in just 1,000,000 years, all the carbon-14 would be gone. I've always heard 50,000 years. All the carbon-14 would be gone. But I've read it could be, excuse me, it said several 100,000 years. But let's say 1,000,000. Let's be really magnanimous. Should we see any carbon-14 in a fossil that's supposed to be that old? No, we shouldn't. But we find carbon-14. If you carbon-14 date these fossils, they carbon-14 date it like 20,000 years old. Huh? If you look at coal, which is supposed to be millions and millions of years old, They're finding carbon-14 in it. Carbon-14 dates between 20 and 50,000 years old. Diamonds are supposed to be billions of years old. Literally, billions over here. They're finding carbon-14 in diamonds. That really messes with them. And the diamonds are dating at 20 to 50,000 years old. Now, even 20 to 50,000 years sounds like a lot, but if you take into account that in the past, the magnetic field of the Earth was stronger, there would have been less carbon-14 added to the atmosphere, and so their starting ratio is wrong because they're comparing it with what it is today, which would bring the dates right down to the 6,000 years that we would need. It's really kind of neat. Anyway, so that's not a problem. Now, other forms of radiometric dating, I mentioned to you, isochron, potassium argon dating, uranium lead dating. They have certain assumptions that the people make. And I'm using the hourglass because this is what the smarter people than I am use. And the hourglass is the idea that if you came in the room and I had an hourglass here, could you tell how long the hourglass has been going? Well, if you could sit there and measure how quickly the sand went down, you might make the assumption that originally all the sand was in the top, and maybe you could figure out how long the hourglass has been here. But what if when I came in here, I flipped it over and it wasn't all on one side or the other? It was already halfway in the middle. And what if I went like this a few times and made it go faster? Or what if I turned it on its side and made it go slower? Do you see what I'm saying? And you really couldn't tell how long the hourglass had been going. And the trick is those are the assumptions that people have to make. They have to make assumptions about the initial conditions. They have to make the assumptions that there wasn't any added or taken away of these different minerals that they're looking at. They have to make the assumption that nobody came in and shook the hourglass or turned it on its side. In other words, that there was a constant rate. And actually, I saw an article that I didn't get to finish reading, but I saw an article that said that even the creationists are now saying that the radiometric decay rate in the past was a lot faster. They're seeing evidence to the extent that it for some reason was faster in the past, and they're not even sure why. So things weren't constant. So radioactive dates can be very, very off. Even though it's a very good technical technique, the dates themselves can be off. In 1986, Mount St. Helens erupted and produced a lava dome. They tested that lava dome, and it tested out at being 0.5 to 2.8 million years old. Well, guys, 1986 was not a 500,000 years ago. You know, that if that's your clock, it's broke. I'm sorry, it's a broken clock. It's not working very well, okay? In New Zealand, I'm not going to try to say that mountain's name, but in that mountain, they had flows in 1949, 54, and 1975, all within the last 100 years, and yet those flows were dated between 250,000 to 3.5 million years old by radiometric dating. That clock is broken too, isn't it? And so, basically, people get all excited about radiometric dating and say, well, but they've proven the Earth is old. No, they haven't. No, they haven't. They haven't proven diddly. And the evidence really doesn't support an old Earth. The evidence, the hundreds of ways you can date the Earth and the solar system, they actually support that the universe and the solar system are young. Helium is actually a form of radiometric dating because helium is a byproduct of an uranium, goes through its decay process and turns into lead. That's what that's showing, is the decay process of uranium to lead. And it produces helium. And that helium is released from the rocks. Because remember, God bless you, helium is, you know, the stuff that you put in the balloons that if you put in your mouth, you sound like Mickey Mouse, you know, or Donald Duck or whatever. You know, helium balloons, okay. And so helium goes up. It gets out of the rocks. Well, they're finding that there's still like 58% too much helium in the rocks, in the granites and stuff, for it to be as old as they're saying it is, because helium hasn't had time to escape yet, and helium comes out very quickly, just like if you let the balloon go, woo, there it goes. Also, the helium in the Earth's atmosphere tell us a certain amount escapes, but not that much. It's way too young. The Earth, it radiometric dates the Earth's atmosphere as being way too young for what they're trying to tell us. But this one says that all the helium in the rocks would have diffused out in just 100,000 years, not even 1,000,000 years, and yet 58% of the rocks are still full of helium. It's not even 1,000,000 years. So the evidence doesn't support it. And then if you go into the stars, if you had physical science, I actually talked to y'all about this, but the galaxies are supposed to rotate, and that's what makes spiral galaxies, and that's called a bar galaxy because it hasn't made one full turn yet. And even the evolutionists will tell you that these galaxies make a full turn every 100 million years. Okay? So that galaxy is not even 1 billion years old, and yet the Earth's supposed to be 4.5 billion years old. So like, what's up with that? How do you find these super young galaxies? And then comets are big dirty snowballs. Those of you that had physical science study about this, and every time the big dirty snowball goes by the sun, it loses a part of itself. That's what makes the pretty tail. And apparently there are 2 other ways that comets can get destroyed. They can run into a planet like Jupiter or something, and they're gone. Thank God they don't run into us very often. Or they can be expelled from the solar system by gravitational forces, which I found interesting. But anyway, even with all that in mind, they should only last like 1 million years. And so if the solar system, if the Earth is 4.5 billion years old, we shouldn't have any comets left. And yet there are all sorts of comets in our solar system. So how the evolutionists deal with it is they say, well, there must be an Oort cloud or a Kuiper belt. The Oort cloud, there's no evidence that it exists, and it's supposed to be outside of Pluto. Okay, the only evidence is that there are still comets in our solar system. And the Kuiper belt, the composition and the size of the things that we find in the Kuiper belt, like Pluto, are not right for comets, and they're too big for comets. So really, there's no evidence that comets come from any place except for when God made the solar system. And these are they're snowballs, so they shouldn't exist anymore if everything is as old as they say it is, because they have to pass through a fire, go by a fire.